Hello everyone, my name is Nikita. I hope it's fine if I have the presentation in English. Want to also involve our guests from neighboring countries and have everyone on the same page. I'm a CEO and founder of Adventum Tech, and over past 10 years I've been involved as a civil engineer, not that much in scientific point of civil engineering and construction, but only in project management. So since I started my career, I was managing projects, dealing with them, dealing with sites, doing a lot of tendering, and my mind works in that direction more rather than scientific. So there are so many smart people here today. I really don't want to measure with you who knows better about the concrete, but let's talk about the risks. And before we begin, we'll have some key takeaways on our presentation. Whenever I work with in situ site projects, specifically in tender, I need to understand that in many cases, specifically when we talk about transport infrastructure, the exposed concrete will be structural and aesthetic. And that will definitely require a special care whenever I tender or then in the end also build the project. I need to understand that improper timing for formwork, because I will always think about time, about the risk, and how should I build the project quicker, save more money on the project and get better bonus. But improper timing of formwork can cause defects, visual and structural. It can cause discoloration, purely aesthetic errors, and also some strength compromises that, again, in my mind, results in complexities, extra costs, and a lot of stress. And something that we'll touch upon today is to deal with all those risks. There's already an existing technology on the market called real-time monitoring. So real-time monitoring is critical to use, in my opinion, if we are really chasing the time, chasing the quality, and want to do everything properly, to the book. And sorry. So let's jump on the project, and whenever we deal with in situ casted projects, this is what we definitely understand, that this is how it's going to look like. And my nightmare is to see deformations like this already during the construction or during the guarantee period that usually is 5 years. This is definitely not something that I want to see. Or during the construction works specifically, but we need to understand that there are some project specifics. If we work with tunneling, and I primarily do tunneling past 5 years, the groundwater issues are always there, but whenever they arise, you always get extra questions and extra attention from the customer, from the customer's engineer. So that's definitely all those risks that I wanna try to mitigate. But when I dive into these risks and trying to analyze them, and again, my goal will be to speed the construction of the project, I have several factors that impact it. So first is the climate, surrounding environment conditions, whether the project is based, some moisture, and how do I treat the concrete, during, so whether that's hot summer and I, from the water perspective, treat it one way, or it's harsh winter and I have to think about some other things. I have also the choice between the type of concrete. I can go for higher grades, even higher than is prescribed in the project, or I can go and try to risk and go with low grades, even though we know it's not possible. And also something that I always keep in mind, specifically in skyrise projects, is the curing time in the formwork. How can I speed up this process and in the end of the day deliver the project quicker? When we talk about now formwork removal, the early removal can cause visual defects such as cracks, surface irregularities, and also some technical issues. And again, I can get a lot of trouble and a lot of extra focus that I definitely don't want to have in my project. However, the late removal can again cause us visual and technical defects that I don't want to have, on my portfolio. I don't want to see on my side happening, and that's something also I need to weigh in. Of course, I have some season impacts that can, high temperatures can cause a rapid drying, it can lead to concrete shrinkage, cracking, and at the same time, if we use monitoring systems, it can overestimate us the strength of the concrete, not matching perfectly to how it is in real life. So I need to be aware of all these things. And the same goes for winter condition. Frost can really slow down the curing process and there are some risks that I need to keep in mind when I do project management. How do I hedge these risks? There are, of course, methodologies and methods or steps, guidelines. I can do constant testing and verify concrete compressive strength on site and in the labs. I can follow the guidelines by designers, formwork suppliers, concrete suppliers, and I can also incorporate real-time monitoring tools and try to control it to deliver the best value. So what do we actually monitor in real-time world? We can monitor strength, we can monitor vibration, we can monitor hydration, temperatures. Some external factors, as I just mentioned, there's vibration, because if we cast fresh concrete and someone is exploding the rock right next to our site, these cracks and vibrations can cause visual and technical defects. And it also provides continuous data on what is happening on our poured, let's say, structure. The benefits, we reduce the guesswork. We try now to focus our decision-making and our argumentation only on real data. And this real data is representing very precise timing, so it can also work on some claim support. We minimize the risk of all these visual and technical defects, and we can really implement many things along the way. So what we do in Adventum Tech, we've created a comprehensive solution for an in situ, let's say, project, where we can additionally to concrete strength and development and external conditions monitor load bearing. We can monitor the impact of surrounding environment, because again, groundwater management, for example, can cause ground to settle, that can cause building to settle, and then again, it leads to other risks. We can control any type of deformation and combine it in one place for very deliberate analytics. So we've produced a variety of monitoring systems that are being implemented on many projects across Europe. We have full telemetric solution, the sensor, the base, and the software. Some examples of, for example, load-bearing sensor that was first delivered in 2021, where we wanted to prove the customer that he has some risk on his load-bearing along his project. Back then in 2021, one sensor would hold 3 tons per sensor as a working load. This year we're shipping the sensors that will hold 1,000 ton on one and will be used as a temporary bridge bearing. So we have some progression in development. We have concrete strength detection sensors that, again, according to ASTM 1074, they do their concrete development calculation. We have some vibration impact sensors that, again, if you equip your sites and you can record external vibrations impacting it, it leads that it can cause some cracks, deformation, and then you can further, again, hedge this risk, hedge these claims that might come to you later. And lately we've tested and implemented the slab control, a sensor that has one sensor in one variety of functions, including temperature, humidity control, vibration detection, specifically in first 28 days when the concrete is developing. We can see the settlements of the structure. It can record any type of deformation, inclinations, concrete shrinkage along the time. At the moment, this solution can hold 20-year lifetime. It's casted in the structure, but we are very close to get it now to 50. So imagine you can cast in the sensor like this. It will live in the structure for 50 years, and you just hedge all your risks that are related to it. And if you are a real estate owner or bridge owner like Deutsche Bahn, for example, they are interested in this solution very much. You cast in every new built bridge and it is there forever. So additionally to all the construction related risks, you can do improved predictive maintenance, you can get quick reaction time whenever any anomaly is spotted, and many, many, many other benefits. We've additionally started testing these solutions in various special foundation projects because we want to implement them in quantities for tunneling projects. Tunneling shafts, according to my experience, are over-designed approximately 3 times, which is not okay for our sustainability goals. Therefore, we want to create, and we are on track of creating digital shaft solution for seek and pile walls. Same thing goes for bridges. You know, we believe that every Specifically, the in-situ casted bridge should be digital already by now, because it's not expensive. You can just deploy, let's say, on the span of a bridge, 100 slab controls like this, and you have enough of highly qualitative data for upcoming 50 years if you are a bridge holder or bridge authority, because again, to all those issues with predictive maintenance and many other aspects, just brings you benefits. So, yeah, we slid a little bit off the topic, but the timing of formwork is critical to achieve the desired visual and technical standards, specifically from project management point of view, because again, our risks and opportunities, so if I can hedge my risks really well, it will definitely turn into financial benefits on my project cash flow. Early removal, when we deal with risks, can lead to surface and structural defects. Real-time monitoring solution ensures optimal decision, real data that can again hedge all these risks and assumptions. And investment in monitoring technologies nowadays is very important for every company. This is my message that I want to spread to many of you. Don't be afraid to implement them in your projects. Don't be afraid to play with it, because only when companies on board and try to use them on their daily decision making, this is the only way how we can drive the change. Thank you very much.